Hi all. So today we will go to the new chapter, chapter 5, which is Fourier transform. So um, for this chapter, basically we will refer to the table as you used the Laplace transform table before this for the chapter 3. Similarly, for this chapter we will use the Fourier transform table. The expressions slightly same. Only few actually have like a difference. Like for example, let's say for the unit step function, you will have like a 2 pi delta omega. But if you see like for this function, it's almost same. Okay. So anyway, the table will be given, and then you can use this table to find the Fourier transform, and from Fourier transform, if you have to go to the time domain also, you can use the table as well. So we will use the table when we solve the question. So Fourier transform, the concept actually same as previously used by the Laplace transform and then the Fourier series to make the solution easier. Okay, because some of the circuit solution you cannot solve in time domain, it will be very difficult. So to make the solution easier, the transform actually used. So for this case we have like a Fourier transform where we will apply in this circuit. Okay, so this is actually like a circuit given where the to call that Vi is actually given in time domain, so you have to change it to frequency domain. Okay, using Fourier transform. Okay, this is actually the answer. So let we try whether we can get this answer or not. Okay, so apart from changing this input signal, which is in time domain to frequency domain, we also need to change the this component in to the frequency domain, where this will have like a 1 over j omega c, right? So c is actually 1, so you will have like a 1 over j omega. Okay, then if you change this one to frequency domain using Fourier transform, you will have like 2 plus 3 plus, if you compare the table here, 3 plus j omega is supposed to be okay, 3 plus j omega. This will have like a 3 plus j omega. Okay, so then the next step is actually to find the V out. V out will be V in times with this xc. We write this xc as xc first. So you will have xc over xc plus r. Okay, so here you have the Vi is actually 2 over 3 plus j omega times x is actually 1 over j omega c over 1 over j omega c plus 2. So we need to solve this expression. Okay, expression So here, if we no need to fully what to call multiply this one, because if you fully multiply this one, then you have to do the what to call factorization to get back this form, to do the partial fraction later. So from the beginning, I think we can just solve this part to make it nicely compared with the what to call the Fourier transform table. So just keep it like this: 2 plus j omega, and this side we try to make it in a proper way where we times with j omega c and times with j omega c. Okay, so here you will have like a 1 plus 2j omega 2j omega. So to make the j omega without any number, we can divide by 2 or times with half, up and down. So you will have like a 2 over half over j omega. Okay, so this is actually the V out. Then what we can do, we actually can use the what to call the partial fraction to get the final answer. So here you will have like a 1 over 3 plus j omega and here you have like a half plus j omega. Okay, this is actually the V naught where I can divide this one to a over 3 plus j omega plus b over half plus j omega. So this will be my V naught, and I can solve my V naught using the partial fraction. The a and b can be solved using the partial fraction. Okay, so a would be equals to the whole thing over j omega times with the j omega, where j omega would be -3. This is actually the a. So so this actually can be cancelled, and if you substitute -3 here, you'll have a equals to -2 over 5. Okay, similarly, to find the b equals to this is multiplied with the 1/2 plus j omega . then this actually be cancelled. So substitute the j omega as a negative 1 over 2 here. So finally you'll get b equals to 2 over 5. So then you write back the equation, negative 2 over 5 over 3 plus j omega plus 2 over 5 half plus j omega. Then we should compare with the table again. This table where you have this function. If you have this like this function, this actually will have like a e negative at,